Everything you see around you feels solid and continuous: the table, the air, your phone, even your own body. But the most shocking discovery in science is that none of it truly is. Matter looks continuous, yet it's built from tiny, discrete building blocks that you can't see, touch, or feel directly. And once this idea was proven, science never looked at the world the same way again. This is the Learning Studio, where we don't just say what science discovered, but why that discovery changed everything. In this chemistry series, we're building understanding step by step, so each idea naturally explains the next, and atoms are the key that makes chemistry possible at all. Most people think everything being made of atoms is just a fact to memorize, but in reality, it explains why matter has mass, why substances react, and why materials behave differently. For example, when salt dissolves in water or iron rusts in air, it may look like matter is smoothly changing form. What's actually happening is that unimaginably small particles are breaking apart, rearranging, and forming new structures. And those particles are atoms. At the most basic level, an atom is the smallest unit of matter that still retains the identity of an element. Atoms combine, separate, and rearrange during chemical reactions, but they are never destroyed, exactly as shown by Lavoisier's law of conservation of mass. Chemistry exists because atoms are stable enough to persist, yet flexible enough to bond and react in countless ways. This idea was first turned into a scientific model by John Dalton, who proposed that all matter is composed of indivisible atoms and that chemical reactions are simply rearrangements of these particles. Dalton's theory explained why substances combine in fixed ratios and why chemical equations balance, not by coincidence, but by atomic necessity. As science advanced, atoms were no longer seen as indivisible. J. Thomson revealed that atoms contain smaller charged particles called electrons, proving that atoms have internal structure. This discovery raised deeper questions, which were answered when Ernest Rutherford showed that atoms contain a dense central nucleus, with most of their volume being empty space. Later, Niels Bohr refined this picture by explaining how electrons occupy specific energy levels, making atomic behavior predictable rather than chaotic. Once atoms were understood, chemistry suddenly made sense. Differences between elements came from differences in atomic structure, not mystery. Chemical reactions became understandable as atomic rearrangements, not transformations of essence. Materials behaved differently because their atoms were arranged differently. In short, atoms became the invisible logic behind all chemical behavior. This atomic framework doesn't stop at theory. It underpins modern medicine, electronics, energy storage, materials science, nanotechnology, and even AI-driven chemical discovery. Whenever scientists design a drug, build a battery, or engineer a new material, they are manipulating matter at the atomic level, whether directly or computationally. And once we accept that everything is made of atoms, a new question naturally emerges. If atoms explain what matter is made of, then how do atoms stick together to form molecules and materials? That question takes us directly into the next episode, where we explore why atoms form chemical bonds, the force that turns atomic building blocks into the material world around you.